Hello. Ask away with any questions. I am ready. Sure. Okay, so I was going through just some difference of squares questions. Some people had asked me, asking to kind of focus on factoring quadratics with focus on the difference of squares. So I kind of wrote them down in like some increasing order of difficulty. So the first one's fairly easy, right? You're going to just write this as x squared minus 7 squared, and then you can quickly do your difference of squares formula and you're done. With the next one here, the idea here is you don't always have to have the variable in the front, right? Like most of them they do, but that's not always the case, and that's what I'm doing in 2 here. What I can do is I just need to write this as a power of 2 and write this as a power of 2. So the 25 here, it can be expressed as 5 squared. Oops. The 25 can be expressed as 5 to the power of 2. So that's kind of what we're doing here. I'm taking the number 25t squared, I'm writing that as 5 squared t squared, which is equivalent to 5t to the power of 2, but then I can use my difference of squares formula. So now this will factor into 10 minus 5t times 10 plus 5t. But you'll notice here that we had talked about this, there's like a common factor here and here on that. And when you do that, that means you could have GCF something first. So I kind of wanted to show that error that does happen. So what we should have done is factor 25 out first, and you're left with 4 minus t squared, which will be 25 times 2 minus t, 2 plus t. And that's like your fully factored answer for number 2 here. Now if you missed that and you got to here, you can still answer that question because you can do, let me give myself some more room. What I could have done here is once I got to here, I could have said, well, I'm going to factor a 5 out of the first one and a 5 out of the second one, right? You can take a 5 out of both of these. And then these two 5s come together to give you your 25. 2 minus t, 2 plus t. And you actually get the same answer either way. Does that make sense, number 2? Like you can kind of tackle that either way. For number 3 here, if you're looking at number 3, there's a couple ways you could do it. A lot of times what people will do is just rearrange this as x squared minus 169, right? Because you do want a minus sign between these, right? So then this will be x squared minus 13 squared, and that'll factor into x minus, that'll factor into x minus 13 times x plus 13. And that's number 3. All right, there's 3. 4, I made up 4 to show you this is, if you're looking at number 4, this one is not factorable at all. Oops. Right, and the reason for that is because of that plus sign here. It's not a difference of squares, so 4 is not factorable. There exists no 5 here. I believe I didn't have a 5. Okay, 5, 6, 7, 8. So there's the second one. I did 3 and 4 as well. Here's 5. 5 to 8. I'll let you take a look at these. If you need me to take these up, let me know. Or you want to try them out yourself. Hey Kinlon, how are you? What's new in the life of Kinlon? How's calculus? Hey Dia. A restaurant on the moon. I have not. What is it? What's the joke? Have I heard about the restaurant on the moon? Wow. Kinlan, these are way better than the jokes that I came up with. Wow, I'm gonna say, and the one last time Dia was good too. The cursor, the mouse. I'm gonna use those. I'm gonna steal your jokes. Very good. You tell those to who you got for? Oh, you probably have Belan maybe for. You tell it to your calculus teacher. Pretty good jokes, guys. Oh yes. Oh, he loves jokes. He loves those one-liners. Thank you, Kinlan. Thank you. I will. I will take them. I will tell them first thing tomorrow too. Well, my grade 10s told me they needed help with factoring. Here I am. We have no questions for my grade 10s on factoring. Oh, really? What is it on, like chain rule or something? Quotient rule? I don't know where you guys are right now. Tangent lines? Oh, you're probably far than that because you have to do vectors too. Hello. Oh, derivatives of trig and exponential derivatives. Yeah. See, but like I told you, just take the derivative and then it's the advanced functions course, right? Take the derivative and solve for exponential equation, trig equation. Hey, Dalal. All right, Dalal, was it you who asked me for a bunch of difference of squares questions? I think it was you. I already put some up here. Here's a bunch of them. So those are recorded. You can check those out, but there's some new ones here. Or if there's other ones you need me to work on, we can do those, Dalal. Yes, I remember. I remember you saying that. I made a bunch up, but I started at 8, so a little bit earlier. But do you want to start off with? You want to try these 4? These are trickier. But I can kind of start off with some easier ones with you as well. Can you please give that? Oh, natural logs and Euler's number. There's so much stuff in that course. You had to pick and choose. Oh, Mina's here. All right, people are here. German's here. Ones with fractions, sure. Okay. Let's make up some difference of squares. And we can try them out here. So I've got some here, but I'll make up some more. Let's save these for the end. I'll do some with fractions as well. Okay, here's a fraction one. Let's save these for way to the end. Okay. So I'll put them on here, and then you guys can try them out. If you're just looking for different types of difference of squares questions, I'll just make some other ones up. Let's do that one. And let's do another fraction one. Maybe something like that. 8? What's 8? Oh, you did, Dia? Oh, great. I'll add it to my wardrobe. Oh, what size? I think I might need an extra large, Dia. It's getting pretty bad. I don't... Sir, what's 8? There's no 8. Sorry, I'm making fun of myself. Okay, I think I'll squeeze into an L. We'll see. I'll take it anyway. Okay. There's no 8 here, Mina. I have 1, 2, 3, 4, 5. But thank you, Dia. That's great. I don't know. Don't know, Mina. Okay, so here's 5 questions, and we can do these later. I think these might... I don't want to do these really difficult ones right away. It's not necessary. Save those for later. Oh, sorry. Okay, well, I don't know what 8 was. Oh, that's smart. Oh, well. Okay, I'll try out these ones here. I added some fraction ones. Gurman was asking for fractions. There's some GCF stuff, difference of squares. You can try these ones out. That'll cover lots of stuff. I'm not going to do much more than that for difference of squares. Yes. Yeah, I can. Do you want me to do them right now? I just wasn't sure if you guys wanted to try them. Oh, please take them up? Sure. Okay, so for the first one here, the whole deal with difference of squares is you have your subtraction symbol, so that's good. And I want to express this as a power of 2. So this is going to be 4, because I know 4 squared is 16, and I know x squared squared. So do you see by writing this, doing this trick, I know that 4x squared to the power of 2 is going to give me 16x to the 4. So, and likewise, y squared to the power of 2 is going to give me y to the 4. Right, because the whole deal with difference of squares, you just need to express it as a power of 2. So now I have here, this is my x, and this is my y. So now I do my formula, and this is going to be 4x squared, that's my x, minus my y, times my x, plus my y. And to continue this here now, we can do difference of squares again. So if I want to do this again here, there is no difference of squares here. You'll notice this is a sum, so it doesn't break down anymore and it's done. This one does break down, so I can write this as 2x squared minus y squared. And then I'm just going to jot this back down. So now I've got difference of squares again that can kick in, right? Where this is going to be my x, and this is my y, this is my x, and this is my y, right? And then we write this back down. So what I have here is my answer for 1. Is 2 good? Are there any questions with 2? Because it's a sum, Dalal. See, it's a sum, the sum of squares, and which is, there's no formula for the sum of squares. Like for instance, Dalal, if I wrote this down, I said x squared, like if I said factor this, you can't, right? X squared plus 100 is not factorable. However, x squared minus 100 is factorable, right? One's a plus and one's a minus. So that's what that is. For number 2, like we always talk about, you want to look for a GCF. The GCF here is 3. So I'm getting 4 squared minus 25. And you'll notice again, once you see those numbers, like you're seeing the 4 and the 25, those are powers of, I can write those as perfect squares. So this will be 2x squared minus 5 squared, which is 3 times 2x minus 5, 2x plus 5. And then that one is done. That's 2. Gurman, did you answer 3 yet? Just curious if Gurman needs me to answer 3. We've lost Gurman. Well, I will answer it anyways. So we need this as a power of 2. So this is 1/3 x squared minus 4 squared is 1/3 x minus 4 times 1/3 x. Well, here's the answer. Now you'll notice here, back to Dalal, and I think we were talking about this today, there's nothing more to do, right? It's down to a linear relation, right? You have a degree 1. It's not like here. Like right here, I had degree 2, so I could break it down more and do difference of squares. I don't have that here. It's done. So this is fully factored for number 3. So that's the answer for 3. For 4 here, they, again, difference of squares. Good, Gurman. For 4, again, I'm writing this as 5m quantity squared minus 4n quantity squared. Hello. And now I do difference of squares. Again, so this is 5m minus 4n times 5m plus 4n. And that's the answer for this one. So far, so good. There's 4. Does anyone want to try out 5 first? It's a fraction one. It's a little tricky. So this one is more difficult. Dalal, how are you making out on these difference of squares now? Do you want these are a little more challenging. I'm not going to be, like, the quiz tomorrow is not going to have just these types of ones. There'll be some straightforward ones too. Just curious if you're getting these. All right, so this one is going to be x over 4 squared minus, now this one, you have to watch out. If you're looking at 5 here, this is going to be y squared over 10 squared. Oh, I just made these up. I just made these ones up. I didn't pull these from the worksheets. I can do the worksheet questions if you like as well. I had just made them up just now. Yeah, there's one right in front of you. Number 5 has fractions right here. X squared over 16 minus y to the 4 over 100. So now I can do difference of squares. Notice the difference here. I needed a y to the 4th, so this is y squared squared. I needed x squared, so this is just x squared. But the idea here is that this is now place of my x, and this takes the place of my y in my difference of squares formula, which, again, to remind you, it's just x minus y and x plus y. So this becomes x minus y times x plus y. And that's that one. There's 5. There's nothing more to do with 5. I can't break this down anymore. Right? Although you see a squared term here, this x, there's nothing more that I can do. Okay, here's 6. If you're looking at 6 here, so for 6, this is my x, and this is my y. It's already written as powers of 2. So this is going to be x minus y times x plus y. And that's it if you're looking at number 6. We should clean this up, so because I put those brackets there, you're going to distribute the minus sign. So this will be x minus 2 minus x minus 1. And this will be x minus 2 plus x plus 1. And you can see here the x's cancel. I just get negative 3. 2x minus 1. And we've got our answer for 6. Sure. You know what? I didn't assign 17J. I can do it. Just to show you, I can do 17J, but I'm not going to be putting that on our quiz tomorrow because we didn't talk about it. But the idea here is this right here we can factor. This is a simple trinomial. So this factors into a plus 3 times a plus 3. I can do 17G. I think I did assign that one. But I didn't assign 17J, but just to show you, this is a simple trinomial here. So I need to think of two numbers that product is 9 and sum is 6. And that's 3 and 3. So I can go like this. But that's exactly equal to a plus 3 squared minus b squared. So now your difference of squares gets applied. This becomes your x minus y times your x plus y. And we end up getting a plus 3 minus b times a plus 3 plus b. Hi Samir, we did a bunch of difference of squares questions. You can check them out later, but we're kind of moving along here. I can do some more if you need it. There's 17J, whoever asked 17J. I can do 17G as well. 17g. Yeah, so 17g is 100 minus w minus 4 squared. So the idea for 17g, you can see here I have a subtraction sign. So I already have the difference. If I can write these as powers of 2, then they're difference of squares. So if I write this as 10 squared, now you see I have this as x squared minus y squared. But then I know this is exactly equal to x minus y times x plus y, where this is my x and this is my y. So this will break up into x minus y times x plus y. So this will be 10. Now, because I remember to put the brackets around that, sure, German, 1 second. And yeah, I can do 17f. After I distribute the brackets, the negative sign, this becomes 10 minus w plus 4 times 10 plus w minus 4. And this is 14 minus w and 6 plus w. And now that's 17g here. All right, German wanted 6. Here's 6 right here. And we've got 17f after. I'll do 17f right here. Yeah, sure, Marie. So with 17f here, you want to look for a GCF, which we don't have a GCF, but this is a little bit harder to see. I didn't assign this question actually, but if you do want to answer 17f, this is how you do it. This is 25. I need to write this with a power of 2, so this is going to be 25m to the 4 n squared minus 4 p to the 4. So the idea here is this is like my x, and this here is my y, right? Because 25 squared is 625. M to the 4 to the power of 2 is m to the 8. N squared to the power of 2, right? Power to power you multiply, you get your n to the 4. 4 squared is 16, and p to the 4 to the 2, like p to the power of 4 raised to the power of 2 is power to power you multiply, 4 times 2 gives you that 8. So this ends up being difference of squares. So this ends up being 25 m to the 4 n squared minus 4 p to the 4 times 25 m to the 4 n squared plus 4 p to the 4. Sure. Okay, yeah, I'll mix them together if you want to try some. I'll make up a bunch. Okay. So here's a bunch. Here's 7 sorts of questions all mixed together here. I'll give you guys some time to work through these, and then we can talk about them. Okay, so give these a shot. I can start to run through them. I'll at least let you get started on them, and then I can jump in and help. All right, so let me at least jump in here. So with this one here, the first you should always look for a GCF with these. So for the first one, we're going to factor out a 2, and I'm left with x squared minus 4. But that's going to be x squared minus 2 squared, which is 2 times x minus 2x plus 2. Okay, that is not a complex trinomial, but that's one example of kind of mixing them together. So the idea is you want to decide what it is, right? So if I look at, I see a subtraction sign, After I GCF this out, this looks clearly like a difference of squares because you have a subtraction sign. It's two terms. Difference of squares is usually two terms, each to the power of 2, or I can make them to the power of 2. For this question here, if you look at this one, the first thing you want to always look for is a GCF. So if I look at number 2 here, I can factor out a 2. And when I factor out a 2, I'm left with the following expression inside. But this right here is a simple trinomial, right? The leading coefficient is 1. So for number 2, I need to think of two numbers that multiply to be 3 and add to be 4. Well, the two numbers that multiply to be 3 and add to be 4 are 3 and 1. So this will factor into 2 times x plus 3 times x plus 1. Right, so that's how you'd handle 2. For number 3, the GCF is, if I look at these coefficients, 3, 9, and minus 30, the GCF here is 3. So I'm going to get n squared plus 3n minus 10. So yet again, I'm left with a simple trinomial. And we need to think of two numbers whose product is negative 10 and whose sum is 3. And those two numbers are going to be 5 and negative 2. Right, those are two numbers that do it for us here. So this is going to factor into 3 times n plus 5 times n minus 3. And that's the answer for 3. Good so far? Are we getting these? Or was I going too fast? So far so good. Okay, there's 1, 2, and 3. If we're at 4 here, so Marie, if you're still there, you're asking for a complex trinomial, this would be an example. Because if you look at this one here, you still look for a GCF, to which my GCF is 7. So I can factor a 7 out of here. And I'm left with 2x squared plus x minus 3. And what I'm left with in the brackets here is a complex trinomial. So now I have to go ahead and do my charting method to factor this. So if I want to factor this, I'm going to have to do the factors of 2 and the factors of minus 3. And I'm trying to get combinations such that those diagonals come out to be a 1. So you'll notice here, if I take these two columns, I'm going to take a 1 and a 3. You multiply those together, you get 3. Then I'm going to take a 2 and a minus 1. Multiply those together, I get negative 2. If I add these together, I get my 1 that I wanted. So therefore, this is going to factor into 7. I have to drop that down from before. Then you read it from left to right. So this is going to be 1x minus 1, or x minus 1, and then 2x plus 3. 2x plus 3. And there's my answer for 4. No, it's fine. I mean, you can use charting for the simple trinomials too. They're just a little bit... It's essentially just becomes product sum. It is product sum when the leading coefficient is 1. Like if I write this on the board and then you say, okay, the leading coefficient is 1 and 1, and this is 4, 1, and 2, 2, then you are doing product sum, because this is the only column, and then once you find the other one, you're finding two numbers that multiply to be. These ones. But yeah, it's fine. Typically use the charting method if the leading coefficient isn't 1. So like number 4 is normally done using charting. There's an alternative method we can talk about next week called decomposition. I've got a lesson on it as well. It's posted. But we'll talk about that as well. So there's 1, 2, 3, and 4. If you're looking at number 5 here, again, you're looking for a GCF. So if I start off with the numbers, I look at 18, 12, and 2. The largest number I can factor out is 2. And then I'm looking at x squared, and x cubed. The largest variable I can take out is x out of each one evenly. So now what am I left with? I'm left with 9 plus 6x plus x squared. And I got that by dividing, right? 18 divided by 2 is 9. 12 divided by 2 is 6. and 2 divided by 2 is 1. I'm taking an x away, so I have no x's. I have 1 less x and 1 less x. So 3 to 2, 2 to 1. No, there will not be a lot of questions like 17. It'll just be more straightforward ones. And now I would rewrite this as x squared plus 6x plus 9. And then this factors nicely. And then here I'm left with a simple trinomial inside. Right? So two numbers that multiply to be, we kind of already did this, 9 and add to be 6 is 3 and 3. So this will factor to x plus 3 times x plus 3, which is 2x, x plus 3 squared. No, we're going to be shooting for just like some simple trinomials, some complex trinomials, some difference of squares. Some of them will require GCF first. And then a couple questions, some questions of 17 nature, and maybe the last worksheet I just gave you style to practice. Okay, so there's another. $17J is right here. I'll check it out in a second, Kerman. There's 17J. I actually didn't assign 17J. Okay. Okay, so Gurman's saying, shouldn't something be... Isn't 3... n plus 5, n minus 2... Oh, yes, Gurman, thank you. Yeah, slight mistake. I just put a minus 3. I meant to put a minus 2 here. Because I even found that right here. 5 and negative 2. Yeah. Okay, so this is all done. And then, sir, can you do a simple square root of 4x squared? I'm wondering if we still square the... Oh, okay. Like if I gave you something like 4x squared minus 25, right? You would write this as 2x squared minus 5 squared is 2x minus 5, 2x plus 5. That would be how you'd handle something like that has that coefficient there. And Nada is saying, would it be wrong if I use charting method instead of changing the order to make a simple trinomial for 5? No, charting, not a charting is when the leading coefficient is not 1. Like if, I see what you're asking me, like if I write this on the board, we usually solve it using product sum. But if someone moves the variables around, it's still a simple trinomial, nothing's changed. It's that you, like you wouldn't solve it using charting. You wouldn't find the factors of 4 and 1. You would mess up all the numbers. When you do charting, you have to be in what's called... So all of the way I did product sum and the way I did charting is you have to be in standard form. So ax squared plus bx plus c is how we worked on them. So like, even though the leading coefficient is still a 1, you're just... If it's written improperly, you're still looking for the number in front of the x squared term. There is no square on the variable. I don't have a square in the variable. I'm rewriting this as a power of 2. So 2x to the power of 2. Okay, good. We cleared that up, Nada. Number 6 here, you want to look for a GCF for number 6. And you'll see I can factor a 5 out, giving me 2x squared plus 3x minus 2. And then we are left with a complex trinomial. So I would normally factor this using charting. And you need to think of two numbers that multiply to be, two numbers that come out to be, the diagonals will give me a 3 here is what I'm looking for. In which case I can grab these two columns. So this is going to factor into 5 times 2x minus 1 times x plus 2. And that's the answer to 6. I just did it right here. Here's a complex. I just did a complex number with GCF. I GCF'd it out. I was still left with complex inside. Now, number 7, if you're looking at number 7, we're going to do a GCF on this. First, does anyone know what the GCF is for 7? What would the GCF for 7 be here? Yeah, very good. The GCF here is 4x squared. So go ahead and factor out that 4x squared. And what am I left with? I'm left with x squared minus 1. Here, let's bring this over here so we can see a bit more. I'm left with x squared minus 1. And then you'll notice here, this is you can do this further. If someone writes x squared minus 1, that's actually difference of squares because I can write that as x squared minus 1 squared. And that'll factor into x minus 1 times x plus 1. So that means here I can get rid of this x squared minus 1 and write it as x minus 1, x plus 1. And now it's fully factored. Yes, always GCF first. Yeah, I'm not going to give you guys a question where it's just GCF. We'll practice that later. But none of that happened here. These all were GCF and then something else for every single one of these that we've been taking a look at. All right, are there any other questions I can go through with you guys? Are we okay? All right, is that it, guys? Do you need any more help from me? We're okay? $17G is right here. Like 17G, sure. Let's see here. No, I didn't assign anything like that. Only the ones I assigned from 17 were ones that I would like consider pulling, or anything from the worksheets. I had posted the worksheet review, like complete review. That would be another example. But try out this one here, Gurman, if you're looking for something like that. It's worth it to try something like, let's do x plus 1 squared minus x to the, I don't want to turn like that. We could try something like this. And then if you really want to make it a little more difficult, you could try x plus 1 squared minus 4x squared. You can try those ones. Kinlan, what's up? Good, Isla. Hey, what's up, Isla? You got 4 minus, which one are you working on here? 4 minus x, 6 plus. All right, let's check this one out. So this will be, what, 5 squared, x plus 1 squared. Got that, and then 5 plus x plus 1. Oh, that's nice. Yeah, please visit me, yes. Nothing's going on, and just sit around my portable there. Boom, so we have this one here, for sure. You know where to find me. So this one here, we get this. So if you distribute this, I get 5 minus x minus 1 and 5 plus x plus 1. So you were right. You get 4 minus x and 6 plus x for that one. That's very good. Period 1, I have, you forgot to distribute the minus sign, German. Yeah, period 1, I have, my class has a quiz. So, but I'm, period 4 or lunch. You can, SB message me, we can see. For this one here, this will be difference of squares for this one. German's, this is x plus 1 minus x. Yeah, I'm 1220 to 1. And then x plus 1 plus x. Is that second lunch? I'm not really sure. So I'm getting 2x plus 1, German, for this one. Oh, no? Oh, is it? Okay, so it is second lunch. 12:20. And this last one here, we can look at this last one here, and then we should probably stop. So for this very last one here, this is powers of 2, so this is going to be x plus 1 squared minus 2x squared. And now I have these expressed as a difference of squares. So this is my x, and this is my y. So you've got x minus y times x plus y. See, x squared minus y squared. And that's it. This one needs to be cleaned up here. Did anyone actually get this? This is negative x plus 1, and this is 3x plus 1. We should factor that minus sign out, but we can see. Good. Yeah, if you're really smart, you can next level and factor the minus sign out, and you're done. Essentially, you're taking negative x plus 1, and you're saying that's equal to negative x minus 1. But again, we're not going to, on the quiz tomorrow, it's very straightforward questions for the most part. And then I'll put some questions like 17 on here that you guys like. Got to put some questions. Sure, perfect. Yeah, actually on Monday you can come in during period 1. But during the quiz, the grade 10s will be mad if we're talking the whole time. But yeah, that sounds good. I am there. I'm also in comp sci period 2, Mackenzie's room. All right. Are we good, guys? Is there anything else that you need from me? We're ready to do well in this quiz tomorrow? All right. That'll be it then. Oh, sir, can you go to the top right of the question? Top right of the question. What? This right here? Oh, the top right of the page here, like that one? I'm not sure what you mean. Oh, the one I just did? Here's the one I just did. There we go. No problem. This will all be available as like it'll upload, I believe, for you guys, so you can check it out right away. Um, yes, yes. Okay, guys. So good luck tomorrow. I'll end the stream and it'll save everything for you, and you can go through it and check it out. All right. So thank you. I will see you.